Smile. Hi guys, we are about to start. Okay, so hello guys. So welcome to today's event, DevSecOps Connect. And in this event it's all about having developers and everyone in the development life cycle so that we can talk about secure development in the development life cycle. So as we're about to start, so we have our host, SoteHub, and our partners. We have SoteHub and Only Devs who have been our partners. So let's just give our host a few minutes to maybe tell us a little bit about SoteHub, and then we can continue. So, Mandaga, that's you.
Hello. Good morning. Yeah, my name is Emmanuel Madanga. I work here at SoteHub as a programs assistant and a data specialist. So I just have a brief introduction about SoteHub. SoteHub, we're based here in Mombasa, Nyali. Just in case you don't know where we are. So what we do or about us, we prioritize a lot of sectors, and we have a vision of empowering MSMEs, that is micro small business and startups and entrepreneurs as well. So we are a business accelerator. So we majorly prioritize 4 sectors, that is agriculture, blue economy, climate smart, and digitization. So in agriculture, we have been able to work with mango farmers. We've been also been able to work with passion fruit farmers, that is in different counties along the coast. And then in the blue economy sector, we've been able to work with MSMEs. Right now, we have worked with 334 MSMEs in Go Blue Phase 1 and Go Blue Phase 2. So these startups are in different value chains of the blue economy, that is aquaculture, tourism, logistic and transport, waste management, and climate conservation. So the aim is to upscale, that is create new green jobs, and also be able to increase the turnover of the startups. So we have some success stories of which I'm not going to talk about. So we have one of our startups, owner known as Gloria Kihara, who is in the tourism sector. We have Dixon, who is in also tourism, doing crab shack. We have Dennis Onkangi, who is in renewable energy, that is Kuza Freezer. Then in climate smart, also in terms of Kuza Freezer, we are trying to conserve our environment. Yeah, our climate, that is, and also have Baustaka as one of our startup. Then we have a Go Kijani app, where our MSMEs can evaluate themselves on how they are saving the globe in terms of carbon emission. That is the application that you can get it in the Google Play. So in the Play Store, you can get it and be able to interact with it. Then in terms of digitization, we've been able to support businesses in no-code website development. So we had phase 1 and also had phase 2. This one enables those who are not well equipped with coding to be able also to have a larger access or visibility purposes in digital space. And then we had a Blue Economy Innovation and Investment Summit, where we were able to invite a lot of guest speakers. That is the Slovak ambassador. We had CS Sport. We had Charlene Ruto with us here. It was in the month of November, late October to early November. Then we had a lot of activities, including beach cleanup, cycling, as you can see. Yeah, so those were some of the Blue Economy milestones that we've made. And also, these are a summary of our project that I've been talking about. The Mango project in Kilifi County, targeting to empower over 1,000 mango farmers. So cashew nut, we worked with schools in Kilifi and Kwale, and then the GIZ passion fruit. So all these projects are donor funded. So we work with MSMEs through donor as implementers. And this is our team. So if you want to connect with us, you can just visit our website to get more information about Sote. Thank you so much for this opportunity. Karibuni sana Sote Hub. Karibu Chris.
Okay, so thank you. That was the word from our sponsor. So we'll just go ahead and start today's session. My name is Chris Mukunya. I'm a security analyst. And today I'll be taking through an amazing session. Just a moment. Yeah, today we'll be looking at DevSecOps Unveiled, how we can integrate security in the development lifecycle. Because as we know, security is quite a crucial thing when it comes to development, right? So yeah, that's what we'll be talking about today. So I need to cue this in. Oh yeah, I've got it. Okay, so yeah, this is me. I'm a security analyst, and today we'll be looking at DevSecOps Unveiled, which is basically what we'll be talking about the how we can integrate security in the development lifecycle, basically, which is all the talk. What is all the talk today is about. Okay, so yeah, DevSecOps. So I know it's quite a big thing, especially in the latest trends in security. You find that DevSecOps looks like a big buzzword that we've been talking about. So, but basically, DevSecOps basically adding security to the DevOps life cycle. So you have the DevOps cycle, you have the development cycle whereby you have the developers, you have the deployment, you have the, but then we add a layer of security so to make it more secure during development, which helps to save time when deploying and producing. So this is the basic. So here we have the basic overview between DevSecOps and DevOps. So in the DevOps, you have your basic plan, you have your the build part, and then from the build you have the testing phase, and then you have the releasing phase, you have the monitor, and then operate and deployment phase basically. So yes. Oh yeah. Uh, good. Sorry about that. Slight technical issues. So in the development, in the DevOps, normal DevOps procedure, we have the whereby you have the you start with the plan, and then you have the building phase, the coding, the planning, the testing phase, releasing, deployment, and then operation phase. But now when now we talk about DevSecOps, you can find that we had a little bit layer of security, so that when you find now when it's the building phase. So whenever you're at the building phase, where basically you try to talk about the product you're trying to build, you try to start brainstorming on which are the possible security issues that will come along. When it comes now to the code, you'll be looking at things like static code analysis, dynamic application testing, and then whereby you now can get to look at the code for vulnerabilities by tools like Sneak, I think SonarCube, that's where they come in. Whereby you can now be able to do inline code scanning for security flows. And then the planning phase, that's whereby you also get to talk about, the planning phase, you talk with the security experts and you get to talk about which ways can this app be made more secure, because what are some of the ways that apps are compromised. You have the testing phase. This is whereby when you're testing the app, you get to look what common loops all are likely to occur during the application. When releasing, you need to watch your deployments, ensuring that whatever the release that you're giving is secure. In the deployment, you need to watch your deployment pipeline for any security flaws. Are you leaking any API keys? Just an example, things like, are you leaking any API keys? Is your workflow correct? Are you going to get like a massive cloud bill for no reason because simply you use the wrong deployment method, or maybe there's a misconfiguration in the deployment? And then from there you do monitoring. This is why you use tools like Grafana and Kibana. I hope I'm audible to everyone. Yeah, use things like Akina Grafana so to monitor your deployment. Then the operation, basically just basically be looking at how is the app operating? Is it operating as it should be? Yeah. So DevSecOps is basically the fusion of development, security, and operation, whereby now we have development and security people coming together, and then we are able to talk about what is going on in the DevOps cycle. So basically, DevSecOps addresses the concerns that you will get through software development. Because, for example, you have like something like a fun fact. A good number of the hacks that have occurred, like software breaches that have occurred, they have occurred where there is a patch available. There's a patch available for the specific exploit that was exploited, but then it was not patched. So these are some of the things that DevSecOps look towards looking at. Is there vulnerability? Are you looking at your open source code, the open source dependency that you're having? Is there any vulnerability that is there? Has it been patched? Have you patched it on your production? That's what basically DevSecOps is all about. So some of the benefits of DevSecOps, these are basically derived from now the DevOps pipeline, whereby you get faster delivery, but now this one, fast delivery with security, because you can be able to remediate security fixes on the go, because if you are able to identify them on the fly and then fix them before, you can even go further. Because sometimes if you, in the normal DevOps pipeline, you find that development cycle, you find that whenever you fix your pipeline, you found a security issues after the release. Then you have to recall back the app, maybe take the system down, and then fix the bugs as you go. But in the DevSecOps, you're able to fix the security issues as you find them. So if there's an issue, fix it and then continue developing. So every stage of the development as you proceed, it's a step forward. You will not have to go back to look for security issues as you approach deployment. So you also get enhanced quality. This is because you have things like code scanning, you have like deployment failure. So if there's a failure in deployment, to avoid issues later in deployment, you're able to check what is going on, and if something is a problem, the build does not go successful and is stopped until it's fixed. So you also get the ROA risk, because ROA risk in some terms of your software, you find that whatever you are building, there is lower risk of getting some of these bugs shipped to development, because at every stage of your development, security was put into consideration. So you get to reduce the risk, and you also get efficiency gains. This is because this DLC basically means software development lifecycle. This is because it reduces for the need for time-consuming security reviews at deployment development. You find that on most cases, you develop an app and then you start doing code review first before you ship, and then after the code review, you then go towards testing the application for security flaws, which takes quite some time before you finally get to release it finally to the public. But the fact that you are doing all these tests on the go, you are able to minimize some of these risks in the software development lifecycle. Yeah, so we can look at a few principles of DevSecOps. I think there are around 7 principles of DevSecOps. So the first one is the shift left security. I think I'll just go into it and basically do have, oh yeah. So this is the shift left security. You have the planning. In the planning, you have the security architecture put into place. When it comes to the coding, you are able to implement the secure coding practices. When you come to building, you get the secure repository for dependency. That means you are able to monitor all the dependencies, whether open source or the commercial ones. You're able to monitor for security flows on the fly, and then you do the application security testing. This can be the DST, dynamic application security testing, or maybe the continuous application security testing. The next thing, you'll be looking at compliance. Different software have different compliance requirements. If you're building maybe a software for a health app, maybe you find that there's the FEPA. You also have the GDPR compliance. In Kenya, you do have the Data Protection Act. You're able to be looking at this compliance, whether you've been able to meet them as you go. And also have the ISO standards for certification, which are basically are able to talk about how good is your software. Then from there, we also have the secure pipeline. This is basically a pipeline for development, because you do not have to like build, you just have to push code, like normally you do, you push code to your GitHub repository. If all the checks are okay, it gets pushed to deployment and production instantly. So you are able to watch the pipeline and see whether everything is secure, so that if there is a bug, it is not introduced to the production, it is instantly fixed before the deployment fails, and that bug is not able to be pushed to production. So we also have the under operate, we have the AAA, authentication, authorization, and accounting. So basically, you're able to be looking who has access to these features of the code, what permission do they have, basically the principle of least privilege. You're able to give someone only the bare minimum privilege they need to do a task. If it's a developer should not maybe have permissions to maybe to be able to change the pipeline for development. Maybe it's like deploying to the cloud. A developer should maybe be able to, his task maybe after pushing to GitHub or maybe whichever, what do you call it? GitHub, GitLab, those, yeah, what do you call them? Oh, version control system, yeah. Whichever version control system you're using. So you're able to be looking, this, if it's a developer, what permission do they have from the code? Can they be able to push to production? Because as a developer, you'll be able to look at, this is a developer, let him have the test branch, that's why you'll be able to push his code. And then there's someone, the senior software developer, his one will now be having the permission to authorize. This one can now go ahead to production. But then the developer should not be able to give the things like the real permission to deploy to production without having to have a review. It's something like pushing to the cloud, who has access to the identity access and management credentials, and what level of access do they have, the fine-grained authentication, authorization, and accounting. Then from there you have the monitoring, whereby you now be able to, in the accounting phase, be able to look who has access to this, so that in case of an issue, you're able to track who did this and what happened, and this is why we are able to get this issue. That's where the accounting comes into place. The next point, you have now the monitoring, where you have the incident response. In case of something, you should have a feedback and remediation for how to fix that in case of anything. So you should have a standby plan for how to go about it. That's basically the shift left security. The next thing we'll be looking at, we have the holistic automation, which is basically adopting end-to-end automation for extensive setting and CI/CD. This is the continuous integration and continuous development processing. So in holistic automation, it's quite important because it basically saves time. We are able to use tools like, I think, SonarQube. Most of these tools do fall into places whereby you cannot be able to test for your software components that you're using to ensure that they are up to par with what is required for security. Next, you have the continuous security testing, which is basically extending security to include automated testing functions. Is basically after deployment, you'll keep monitoring the application and the entire build process for security vulnerabilities, and also so that you can be able to fix them because you have your dependencies. So that's why we'll use automated testing functions like dynamic application testing, and then you have things like SAST, and which help in ensuring the build is thoroughly analyzed for security. Okay, the next thing we have DevSecOps. This is the collaborative culture and communication. This is whereby you're basically trying to look at the security personnel. We have the DevOps, you have the developer, we have the QA, the QA team. We're trying to bring them together so that all towards building good software that is also secure. So this is what we call about the collaborative culture, because each and everyone is involved at each step of the stage. They're able to enhance the communication of all the teams that are involved in a software development lifecycle, the SDLC. Next up, we have security as code. This is basically treating security policies and procedures as code for automated workflows. This is whereby we have things like, it's getting hard. It's disappearing, but we have things like, I think Sneak is also among them, where basically we are looking at, when we are having Sneak with one of our sponsors, we're looking at things like, when in your code, what is there that is now being implemented? Is your code safe for deployment? Is it good to deploy? That's what we're basically looking at, security as a code. And then we also have tools like SonarQube still comes into place, and we also have GitHub, Dependabot. Yeah, Dependabot does it do in real time, but if you do have it, the Dependabot, it also does the same thing. We also have Amazon Q, not really Amazon Q. I think Code Whisperer. Yeah, I forgot about the one for Amazon. Yeah, but basically that's the entire thing. So the next step we'll be having it, the traceability, auditability, and visibility. We're able to track. We have things like version control. We also have like code scanning, whereby you're now able to look in the documentation who worked on this code base, what did they do to the code base, what changes did they make, are they good for deployment? there's a security fix. Is it really a security fix? Because you now have to validate. Someone may be pushing software about a security fix. Is it actually a security fix? Is it a bug that has been introduced in the system? That's we'll be looking at now under the traceability, whereby you'll now be looking at everything that is going on in the entire cycle. You're able to look at it and present it. So next we'll be looking at continuous improvement. This is basically security is an ongoing thing. So when it comes to security, you'll be looking at every time. You'll be looking at, are there new changes? We have new vulnerabilities that are coming out. What more can we do to make the user experience better? If not the user experience, the development life cycle better and maybe even faster. Yeah. So some of the best practices for DevSecOps, we'll be looking at shift the culture. Yeah, this is one of the hardest things basically, because most of the time you find that in most cases you have a team working on an individual project and the only thing they'll be looking at is the project status and updates. So like whoever is your supervisor will be, have you reached on the project? I'm almost done. And until like you push your code, but they do not really have that much overview of what you're doing. So you find that it's quite a big deal because of the person. So you find that the person who's supposed to be deploying is waiting for the developer. The developer is on this code base. Maybe one is working in the front and the other back end. Find that it's quite a big thing. But now, whenever we try to bring now everyone together, security person, the developer, also get the developer to be security cautious in the development, because on most cases find that I'm just a developer. Security is not really my domain, but it's actually everyone's domain. So we'll be looking at now the culture, so that we can get now to look at how do we get everyone to work together to develop the software at any given stage. So if it's the developer, whenever we are like in the planning phase, the developer is aware of the security configuration that's supposed to be looked. While still developing, there's a security person who's there to look at what's really going on. Now that's all about the culture, because on most cases it's like one stage, if there's an issue, back to the developer, and then a few more weeks. It basically delays the process. But if now we are able to now integrate everything all together, everyone is working at the same time towards on a project. That's basically helps save time and makes the development life cycle better. So the other pattern is define our requirements and metrics. So basically this is all about establishing the minimum security baseline. So we do have a few industry guides that basically look at the security requirements. We have the common one, the OWASP top 10, the Open Workload Application and Security Project. So the OWASP top 10, which is basically, I think, can you open the link? Yeah, sure. So this is basically the OWASP project, which is, where is it? Oh, yeah. Oh yeah, the OWASP project. This is basically the top 10 most security vulnerabilities that do affect software during development. The other one, we do have the SANS top 25 software errors. These are basically mostly things like the logic bugs and things that developers basically fail to do when developing. This is some of the things that you can be able to be looking at before while developing. These are the metrics. So you'll be looking at the developers, the deployment guys, the person who's in charge of the UI UX, so that you can be able to put this into account. So are we secure from this? Are we solved it? Because at the end of the day, there's no need for you to go back to fix an issue that you could have overlooked it in the first place and developed without it. Oh yeah, so the other thing is starting small basically. You don't have to start big with some of the big expensive software and all that complicated stuff about security. You can just start small, things like inline code scanning. It's just basically the basic one. You can do like inline code scanning and you'll find that it'll actually improve quite a bit, because at the end of the day, your software, you'll get a few alerts on things that you've maybe misconfigured, some of your functions not written to standards. And yeah, just as simple as that. You don't have like to have an entire team working around the clock on your software. You can just start small and you get to build securely. So the next point is implementing automation. This is because when it comes to automation, it saves time and you are able to catch errors that normal manual review cannot really catch. This is because you are able to configure the rules and some of the issues based on previous vulnerabilities. Comes to a human person, you can Yes, it's good. It's always recommended to have someone do normal review. But then with automation, it helps to simplify the process, and you can just write rules that basically will say if this condition is not met, do not deploy. Please cancel the build and give the developer a huge error until they fix it. Yeah, everybody loves bugs, so that's an extra bug for you for not building securely. Yeah. So by automation, you are able to do some of these things that help simplify the entire process. Things like scanning your containers, inline your APIs, whether they're exposed or whether they're exposing credentials, that things that should be exposed through API endpoints. Just with simple automation, you can just be able to check, write rules, and then check whether these things are met. Next up, we can do like threat modeling. This is basically whereby you assume you're an attacker, and then what points of your software or product would an attacker be likely to attack. This is you now trying to think like an attacker. So what's likely to be attacked? We have, maybe it's the login page, there's the payment system, someone does not want to pay, so they'll try to attack the payment system, see if they can crash it. We have the database, can someone access other users info, do things like the IDO, things like that. So that's all about threat modeling. When now you try to look at these things, you now try to see, have we fixed all these issues that an attacker may be able to look at? Are they fixed on our end? If they are fixed, then you go ahead and continue with the development. So how to fix them? If you find one of these issues that are there when you're doing your threat modeling, you now try to fix them, and then some of them are more critical than others. So you'll of course prioritize the critical issues, and then the rest go on as you go. Okay, I think I did do this. Implement automation. Yeah, I think I did do this. The automation must have been a repeat. So automation again is quite good. So the next thing is managing your dependencies, because dependencies, they are quite important. You have your node packages, npm, is it? Yeah, JavaScript packages. If you're using Python, your Python modules. Some of these modules do have vulnerabilities occasionally. It's always good to monitor them, monitor your dependencies, and see is there any vulnerability in one of your dependencies. Like a common one, we have the one that had come up so recently. We had the log4j. This was basically in Java. It was quite a critical one. And basically, though a patch was then available, but you even find that even after the patch was available, 3-4 weeks later, or even a month, not everyone had patched the system despite being a critical vulnerability. So this is what we're talking about. Manage your dependency, look at them. If you have them, patch them. If you get one of those security alerts, try to upgrade them. Yeah, for Java guys, I know it's always quite hard to upgrade your application because Java is quite complicated, but yeah, you still have to do it because you need to build securely. So your dependencies, that basically once you look at them, will be good to go. Oh yeah, you also need to evaluate and improve. So assess how the process is working, and then look at which are the key areas which you can improve. For example, you find that when building, we're getting so many alerts based on this issue, maybe some of the dependencies from this project, then maybe look, is there more secure, stable alternative to this dependency? Instead of every time having to update it or maybe patch a security vulnerability, because some get vulnerabilities more often than others. So you try to look at the alternatives, and so as to avoid every time you're always fixing something on your production code, so that you can get something that is more stable for the long term. Also collect data. Data is actually important. It will help you to know if there's an issue, in case of anything happens, that I will try to tell you what is going on and what went wrong. Yeah. So some of the challenges that are in the DevSecOps implementing that people do find, we do have lack of security assurance at business and project levels. So this is basically, there's uncertainty about the adequate of appropriate of security practices for business or project needs. Find that the security requirements are not exactly defined in some of these projects, so you do not really get to access the correct to build securely with all the correct measurements in line. So one of the approaches you can do is assess the industry specific security requirements. For example, if you are in the health sector, I talk about health sector much because I've dealt with it quite a lot. So if you're in the health sector, look at what are the compliance, the ISO standards required for medical issues. Look at them, look into them, and then ensure you are compliant with these. With some of the regulations, like GDPR, I think the FEPA, yeah. Look at it, and then are you compliant? Have you fulfilled it? And you just go about with it. So the other one is the organization barriers. when it comes out to collaborating, tooling, and culture. Yeah, some of these organizations find that well. It's quite common. It's quite common. You find that the collaboration is not really there. So you find that everyone does their own thing at the same time. So you find that the developer does the building and then writes a nice README for the person who's going to deploy to follow the process. Then the person who's in charge of deployment just comes, follows the procedure. Then, so if there's a problem in the code, the person who's deploying will just deploy as is. So it's quite an issue, and sometimes it's expensive because you require additional personnel for this, or the job description for one developer, sometimes one of your teams will maybe go above and beyond what maybe was in the job description. But it's a small issue. It's not really a big thing. But you can, like I said, you can start small and then you can document the process, build collaboration. Then with the time, it becomes a culture whereby it's now not something new into the industry. It's something that's a culture. So if you bring in new developers or a new team, they find that there's already a culture of DevSecOps in place. So all that will be going on is just catching up from there. So it does not look like it's extra work. It just looks like it's part of the job. So the next thing you can do an impact to quality. So there's basically security teams are mostly involved too late. You find that in most cases get involved when there's already a breach that has occurred. Maybe you've realized maybe there's an kind of compromise. That's when you start finding you're not being called upon to maybe try to look at it. But if you start improving security early from the ideation stage, you're building this app, this is what you want. Call in a security guy, let him maybe look at a few things, give a few pointers. When you go to the design phase, call the security guy in, let them give a few pointers, and along the development process, this is our development pipeline. How do you think? You find that some of these things will be eliminated, basically. You'll not be having some of the issues that will be coming on. Sometimes being hackers is normal, but the thing is, we try to make it as hard as possible for the hackers. That's the whole goal. We can never be 100% secure. Yeah. So the next thing, we have the lack of confidence in the release, and then system complexity. I'm just going to combine because they're kind of a bit in a way. So the complexity and the lack of quality is because sometimes you do find that, wow, you have like one application, or maybe like a company on the entire like deployment, they have like hundreds of containers with different endpoints all working together, that there's the 100 like virtual networks, there's a few load balancers in between, and then you have lots of API endpoints working together. And this is quite a challenge to keep track of, because you find that there's a few networks in between, there's a private network, several public networks, or interfacing with like maybe one or two or three, maybe four different applications. Look at maybe the deployment of like 100 containers, or maybe thousands sometimes of containers deployment. Some goes even further extensive, because you find that desktop applications, you find that maybe hundreds of desktop also involved. So you have to like keeping track of all that basically in the production. It's quite a complex task, because it's quite a lot of things to be on the lookout for. So yeah, so that it's basically there's no really, the approach for that is basically from the DevOps pipeline, maybe try to look at the security in it, and as you go about it, you'll find that some of these things, even though it's quite complex, you find that some of these issues will be mitigated, because now you have a good documentation, all the assets are properly and easy to manage, because there's a good accountability for the assets. And then you also find in security, there's now the accountability and authorization. You know who has access to this, who's in charge of this. It's not like whereby one part of the production has failed and you're like, who's supposed to fix this? Call this developer. The developer is on another code base, on a different code base. So, but then when you have clear guidelines on who's supposed to be working on this, even a complex system gets to become easier and easier to manage, because that's the whole point. The other thing is the lack of security skills. Yeah, this is quite a big one, because in most places you find that there's no dedicated security person, and basically it's the head of IT who's in charge of security, and he's not fully trained for security. It's because he's the head of IT, is basically it's his job description, but when security wise comes, he's not fully trained or equipped for the task. So it's quite a big deal, and you find that, and also getting a security person is not really cheap, and for most organizations it's quite a lot, and having maybe a dedicated security person. So, but if you can try to implement some of this, basically everyone has a little security skill, and maybe like get someone from outside consult, maybe an outside counsel maybe once in a while to come for consultation. It will help increase security while minimizing the cost from the business. You have things like the MSSP, managed security service providers. You can engage them because it's cheaper than hiring an in-house security person who's basically be looking at your security posture, come in, help analyze and look at your production. You also sometimes get, it's not maybe one person, it's a team that you do get. And the other thing is the insufficient security guidance. This is actually quite common here in Kenya because you find in some cases it is there, but actually some of these laws are there, even the constitution, but it's not well known by people. So you find that it's more of a laxity from our end more than the government or the security responsible measures, I mean the also the data protection officer. So you find that some of these issues, it's not really they are there, but they're not really well known. You find that if you go to most people, you find if you do ask them about it, well, not many people have an idea about it as much. They only have, it's supposed to be secure, but if you do ask what the security you're talking about, no one can hack. But what are you exactly preventing? Because there are quite a lot of bugs that you'll be looking at, and you need maybe to let them know what they're building against. The OWASP top 10, the SANS 25, which are the common ones. So the developers need to be aware. These are some of the things that we are looking for, and so they're not there in the development. This is so you can prevent them. Even when they're building, some of these things are already eliminated by default because everyone is aware of what they'll be looking at. Yeah, and that's the end. Sorry for the memes. Programming humor channel on Reddit was not really available to me at the moment. So, any other question? Any question, Ali? From the okay. Okay, so thank you guys, and that's the end of my presentation.
Okay, hi guys. My name is Rachel Olwosh. I'm a website developer currently at Polytechnic Girls. I will be taking you guys through a deep dive into website security. So we'll, we'll go through WordPress website security. So we'll be exploring essential features and plugins for enhanced website security in WordPress. Yeah, so why WordPress security matters. So the first one is popularity and target attractiveness. WordPress is a very popular content management system, and unfortunately, this comes with a lot of people trying to get a piece of it, trying to get into people's system and gain unauthorized access. So it attracts a lot of negative access, let's say. Then we have user data protection. WordPress hosts data for very many people, and there is data that should not just be randomly accessed. So WordPress has to be secure to ensure that people's data are well protected. Then we have business reputation. WordPress is a business and they would like to keep a good image in the society. So they have to keep the user information secure, they have to keep people's websites secure. Yeah, then financial impact. So security breaches bring a lot of negative impact on the financial sector for a company, especially a big company like WordPress. So it has to be secure. Then search engine rankings. So search engines like Google, yeah, they they organize the systems in a manner that they consider the most secure systems, they consider systems that are safe for users to use. So when they are ranking, they want to rank outside that is very secure. Then so core WordPress security threats. So we have brute force attacks. Brute force attacks happen when people try to, like, if someone is trying to log in and they are using passwords and username, they'll try to use like several passwords, several usernames to log in to a site if they are not authorized. Outdated software. So WordPress hosts softwares like plugins. They use plugins and themes. Using these can put your website in an insecure state. It can put your website in jeopardy, and people might easily access your website through the back door if you're using outdated software like plugins. And then we have unauthorized access to the WP admin. So this is when someone accesses your WordPress dashboard through the back end. This poses a lot of, yeah, if someone accesses your dashboard, they can easily make changes to your website, even if changes that are not needed or changes that may affect your business and your website generally. Then malware injections. This is where someone just randomly put, so if let's say you're using the outdated software, someone can put in malware that into the outdated software if they figured there was a place they could breach. So they put in the malware and it affects how your WordPress site works. Then phishing attacks. This is when an attacker wants to attack your site, so they may send like emails or documents that are supposed to be helpful or show to be helpful so that your user can put in their information into the documents or, yeah, and collect their data. When in the real sense, this is just to collect data illegally. Then SQL injection attacks. This can happen in forms when someone puts SQL code into your forms. If they know there is an opening or there is a chance for them to breach your system, so they can put in SQL code into your input forms, and this allows them to illegally access your WordPress site. Then we are now how we enforce the security into the WordPress website. So core security features, password and strength enforcement. So you have to use strong password. So mostly these days people use like a phrase or a name of a place and they just change the characters. So for example, you could change one to an I or an I to a one, yeah, to make your password more stronger, to make your password stronger, yeah. And then two-factor authentication, this is mostly seen in Google when you're logging into Google sites or when you're logging into social media sites. So you can use this in your WordPress website, whereby when someone tries to log into your website or tries to access information, they have to give an email or you have to send a code to their phone number that allows them to access your website. And then we have regular updates and patches. So this is with the plugins. You have to update your plugins. They have to be up to date because mostly people update plugins because an attacker may have figured out a breach or an opening in your network that they could use. So the updates are brought up to deal with the breach or the opening so that the update comes in with the breach already handled. And patches, this happens when, yeah, this also happens when there is a breach and they have to the website, the plugins updates have to be made to cover up the initial opening in the previous plugin. And then we have authenticator app. So an example is Google Authenticator, where user you have to with Google Authenticator, you are given like a barcode. Yeah, okay. Google Authenticator sends you like code. So when you're trying to log into your Google accounts and log into your social media accounts, Google Authenticator gives you a barcode or a code to scan that allows you to access the apps, and they only allow it for a certain duration of time. So after you're given like 2 minutes, when the 2 minutes are done, you can't use the code anymore. You have to get another code. And then installing SSL certificates. So these are security certificates that are meant to detect when there is a strange access to your system. Then essential WordPress security plugins. So we have WordFence and Security. So WordFence offers firewall protection, login attempt monitoring, real-time threat defense, and two-factor authentication. So firewalls are mostly used to monitor the traffic in a network. So they can keep track of the traffic that your network um, receives, and when there is traffic that doesn't seem to go with the network or doesn't seem to normally work with the network, they alert you. Then we have login attempt monitoring. So this is shown when someone tries to log in, will say they give you like a number of times you try to log in. So they have to monitor your password and your username and monitor how many times you try to log in. So they give you like 3 attempts, and then the account has to be closed for some time before you can continue. Then we have real-time threat defense. So they keep track of your website every time. So in case there is a threat coming in, they let you know. Then factor authentication, just like I said, you're given like you have to give when you're signing up, you have to give like an extra email or a phone number where you get a code. Then the code is what authenticates you. So I'll show you guys how we can sorry how we can access the word fence. So I'm going to use an example with the dashboard of Utafiti Data Hub. So just to show how WordFence works. So yeah, to install WordFence, it's a plugin. You go to the WordPress plugins menu to the left of your screen, and you can search. So you can add a new plugin. So that is, you can download WordFence from their official site. So that's wordfence.com. You can download the plugin from there, or you can directly just search a plugin here. So let's say you're adding a new plugin, you come here and then you search plugins. So you search WordFence. There. So here, then you can install it. So mine have already installed, so it's active. So I'll just show you guys how it works. So yeah, when you install, you get the icon comes to the left side of your dashboard in the list where you have the menu, and you just have to click on the WordFence icon, and you'll be taken to the WordFence dashboard. So here, they yeah, this is how you access. So here it's showing how the WordFence works, the firewall, the scan, and then we have the features it applies. Let's say the firewall. So yeah, you told the WordFence firewall protects your site from attackers. So this is where you can monitor what WordFence is doing to protect your site, and also you can manage the options to optimize the firewall's configuration. So this is, you're given just an overview of how WordFence, how the firewall part of WordFence, the firewall application of WordFence works. So it blocks known and emerging attacks using firewall rules. So when you install the WAF, it will be in learning mode, and this allows WordFence to learn about your site so that you can understand how to protect it and how to allow normal visitors through the firewall. And then brute force protection. So this is where it protects your site from password guessing attacks. So yeah, it sees someone is guessing passwords, guessing usernames. Yeah, it detects. And then firewall options. This is how it guides you on how you set up your firewall to protect your website. So on the dashboard, on the WordFence dashboard, we have how the firewall part works, then the scan. Yeah, we've looked at the scan. Yeah, and then we have Securi. So Securi is also a security plugin for WordPress. So what Security does, it monitors website integrity, it removes malware, it sends you notifications. So when you first sign up for a security plugin, you have to input your email. So when they detect a breach in your system, they'll send you a notification to your email. And then blocklist monitoring. So blocklist would say apps or sites that tend to flag your website. So if your website has issues, it will flag your website. So Security lets you know if your website has been flagged. So I'll show you guys how Security works. Back to the Utafiti Data Hub dashboard. And so to install Security, we still go back to the plugins. Yeah, and then you add a new plugin. Yeah. So you could upload if you get the plugin. You can get the plugin from the official site. So for WordFence, it's wordfence.com. For Sakuri, it's also sakuri.com. You search on Google. So yeah, to you search here. So yeah, when you click add a plugin, you can search here security. There, and this is it. So I've already installed mine. So when you install, you get the icon here. Yeah. And then we open the security dashboard. So in the dashboard, it shows you. So we inspect WordPress installation and look for modifications on the core files as provided by WordPress.org files located in the root directory. So they have the files from WordPress that are located in the root directory, and then they compare this to the files that are distributed in your website, the files that access your website every day. So here it shows audit log. So this is what the actions that have happened in my website. So today, so I activated WordFence after I installed Security. Then I deleted multiple entries. Then I added a media file. So it gives you a list of the activities that are going on. So that is how it monitors your system. And okay, so it was supposed to show the block list site. So when it detects, if it detects when your website has been blacklisted. Okay, the list normally appears on this side, but it's not showing it now. So yeah, so it will show you a list of the blocklist sites. So the sites that have flagged their website for blocking, and then if there is any and you feel there is a misunderstanding, then you can easily check it out. Yeah, so that's it for my presentation. Anyone has a question? So I said they have official sites. So for Sakuri, you can go to sakuri.com, you search on Google, and they are also on the website WordPress plugins. So when you go to the dashboard, the part where you have the plugins, you you add new and you search for, yeah, you search for the plugin name on the plugin WordPress. So we have free and we have premium. Yeah. Okay, so for Security, they offer like API integration. So you can't get the API integration in the free version. You can get it in the premium version. Questions? Thank you.
Hello. Uh, I'm Elijah. Um, I'm part of the hosting team here. And I will be presenting something with you also today. We have had amazing speakers who have talked about DevSecOps Unveiled, uh, but also Rachel, who was delve a little bit deeper into securing WordPress sites. So I just want to kind of keep the same way uh, and trying to show us well something about securing the development cycle. We are developers, right? And who would actually take this bus or the tuk-tuk or the motor and come here knowing that the motor wasn't secure? Nobody could ever try that risk. So I think it's just the same thing that applies to us as developers. Whenever we are building, it's like whenever we're building products, it's like we are trying the journey. We are starting on a journey, and we want the security to be part of that journey till the journey ends. So we're just gonna add a little bit of spices into that, and try to see how, okay, like a friendly demonstration of how we can incorporate security as part of our development. And unfortunately, I'm not able to do like the coding, the fun thing with you. So it's just gonna be demo. If we had a good setup, that would be actually great, amazing. But so it's just gonna be demo. Bear with me, because I can't hold the mic and be touching my laptop at the same time. So I'm just gonna go through an already built up and go through the same process. Just yeah, gonna bear with that. Uh, so we're gonna go actually through what are we gonna build first of all. So we're gonna try to look into a Node.js service. I think we are all familiar with JavaScript, right? JavaScript is for everybody. So I know we probably are all familiar with JavaScript. So you're gonna go with Node.js. We're gonna try to build a Node.js service with Nest.js, of course. And then we're gonna try to establish a communication between two services. So the intent is to see how can we actually make sure we are protecting our communication, that chain is protected. In Chris's talk, he actually mentioned something about API key security. We are just gonna try to have a glimpse into that. How is that possible? How do we achieve that? But also, we are also trying to see how we can have a more broader security with our API endpoints. Uh, we're gonna see. We're gonna see. Let me not dive into it. So, enough with the talking. Let me just bring the codes and let's start just going through it. So it's over here. I'm just gonna do this. Okay. Wow. This is gonna be fun because I'm not able. I don't know how I'm gonna stand, but let me do this here. Okay. Maybe like this. Maybe this is better. So nice that. Is that good? Or you also suffer from eyes like me? Can everybody see there? Or can I change the light more? Different size? Okay. All right. Yeah. Is that better? Maybe more. Connect 30. Good. Okay, that's good, right? Is it okay? Up there? Okay, cool. Yes, so as I just said, we gonna go through two services here. As you can see, right here we have a notification service and we have an event service. So this event service, let's consider it as a service where you're gonna be registering for certain events, like DevSecOps Connect. So you have to register. So you're gonna expose an API endpoint that users are gonna utilize to register to events. But also it's gonna provide as well another API for to list reservations. So of course. And you're gonna have the notification service. So what we're gonna do is just we're gonna mimic, because it's not sending any notification, but the purpose is to send a notification. We're not sending a notification actually. Well, so let me go just through it real quick, just a demo. First of all, this is the event service. So to people who are not used to Nest.js, bear with me, but it's still JavaScript, and JavaScript I hope you just understand the idea, right? So I just have some seeders here, some data seeders, and these are just some scripts. And what we are doing is just inserting some data to play with, because we are actually not going to be dealing with data inserting all of that. So I just insert some data to play with. And apart from the seeders, I have the controller here, and you can see that the controller is exposing this API endpoint, API/reservation, and it's just there to list the reservations. And we have another one to actually make a new reservation, and we have another one to list the events, and then some other one here actually. And then I also have the service class right here, and what the service class is doing is just connecting with the controller to just serving the controller and connecting to the database through the Prisma client. And then I have this middleware, we're going to check it later, and then the application is just running on that port here. So just basic things, no, not basic things. And then on the notification service, I also am exposing. Let me go to the controller. Oh, yeah, I also have a controller here, and this controller is exposing as well one API point to send email notifications. And actually, basically, that's only it. So let's just do a quick test. So I'm going to bring my API client right here. Sorry. I'm gonna bring my API client. Let's try these endpoints and see what they're doing. I don't know how I can zoom, but I hope you can see. Yeah, wait. Control plus. Thank you. Good. So we have this API here, which is actually listing our events. So you can see I can call it, and let me hope I get the list of events. It didn't. Okay. It's not running. Okay, just a minute. Good. Mhm. Yep. And yeah, you can see we have the list of our events right here. We have this second connect, and actually people who registered already. Of course, I had some data in the database, you understand. Um, yeah, so we can as well make new reservation right here. Just click it here and sending this to data, and you can see the user has reserved the seats. And we can as well list reservations. So just actually a demonstration of the API I just showed here. Yeah, and lastly, we can send as well an email. So you can see what's the concern actually here is that the notification services, they are, it's not actually, we're not talking about microservices here, but we're talking about two services that kindly somehow don't know each other. So you can take it as, who uses Twilio? Who has used Twilio before? Some of us. Or SendGrid. I'm pretty sure you're familiar with those services as well. So you may use Twilio to those who don't know Twilio to maybe send texts, sorry, SMS messages and other things. You can check their websites. You can use SendGrid, you can use, there are many third-party services that you can integrate into your application. And you see, it's another service. They don't know you, you don't know them. So how do you make sure, or how do they make sure that they trust you to use their services? So you see, there's got to be some kind of identification to know that this is actually Elijah trying to connect to us. And we take the same thing with the notification service. So the event service and notification service somehow don't know each other. And they want to communicate. So the event service, I'm building an event service, but I want to connect with the notification service to be able to send notifications. So the two services don't know each other, but I'm coming then, I'm going to the notification service. I'm like, okay, boy, I want to use your service. The notification service will not let me use your services just like that. They will have to know who I am. So I'm going to register. And when I register, they're going to provide me with a key. And that key will be a private key that's going to identify whichever communication I will try to establish with the notification service. So whenever I'm going to hit the notification service endpoint, which in our case is the send email API endpoint, I'm going to pass a key. That key was issued by notification service. So I went to notification service, I created an account, and notification service said, okay, we are giving you this key. Whenever you want to use us, use this key, and we're going to know that's you. That's going to identify you as one of our subscribers, one of our people. So I'm going to have to pass that private key whenever I'm hitting the notification service. And that's actually the intent or the idea behind this model here of schema. So we are trying to mimic that same scenario where we have to protect a public API endpoint from an unknown source because we don't know who's the user going to be, but still want to identify who they are. How do we do that? Through now the concept of API key as one of the ways. Not the way, but one of the ways, right? We can achieve that. So how did we implement that through this application? Let's then go back into the code and see. So you can see that in one of my classes right here, in the notification service, I have, let me go to, I'm gonna close that. And the source, I have this, where is it? Client tab registration service. So what this actually is doing, nothing big, it's just assuming we have a whole registration process that happened for a client to register. So the client in this case is the event service. So we assume that event service logged in the notification service and they created an account. And after creating the account, notification service issued them an API key called my secret API key. Right. So we assume, of course, we didn't implement the registration here. So what is this key going to be used for? So whenever event service want to access notification service, event service will have to provide this key. And if they don't, then the request is going to fail. It has to fail because notification service will tell, okay, who are you, boy? Why are you trying to diffuse me? So it has to provide that key whenever it wants to connect to the notification service. And that's actually what we're doing here. And we have this method of this class. What it's doing is just returning that, nothing crazy. But you understand that that should be a real validation of the key that will be happening there. But here it's just for demo purposes, just to show the how we can implement it. But that should be probably a database call. You check this key, this user, are you the one logging in, all of that stuff, and you just put them there. So how are we then? We see here we are registering the application and giving the third-party user an API key. How the API, how does the client put the third-party user now giving us back the API key? So whenever notification event service switches the clients, when I connect to the notification service, they will have to pass that key, my secret as you saw there, in some ways. And in this case, we are actually passing it through a header. So we can go to app service and here we have this thing here, make reservation. So what's the idea here? So whenever a user is making a reservation and we have saved their reports, we want them to send their notification that, hey, your seat has been reserved, something like that, you understand? So when the user is just making the reservation here and all has gone well, we are calling the notification service right here. And we are saying, okay, go, man, just send the notification, send the email notification. So what is this method doing? So let's just navigate to it. If you go there, it's actually under notification service TS right here. You can see we are connecting to the other API, send email. But whenever we connect to it, what are we doing? We are actually passing one header here called X API key. And we are passing my secret API key right there. So if you make that header, notification service is going to check, did you really pass this header? And if it doesn't find it, you tell, okay, well, I don't know you. You go away. Where are you coming from? And it will reject the request. But whenever we have this header, actually as part of the request, notification service will know who you are and will actually let you move on and send a notification. So let's do something crazy and just add this slight change to this. You can see that as well, something, I don't know if you paid attention, but if this request fails, actually we are logging something here, but let's not log, let's actually throw that exception. So if you throw it, it will show very well in our API clients, Postman, and it will show that the request is going to fail. So let's just remember, we just made a slight change to the API key, which means now the API key is invalid, right? So we're expecting now this request to fail. So go to Postman again, and we try to make a reservation. The seat which was reserved before, now it's gonna say you are trying to make a bad request because the key you're giving me is actually not the key I'm expecting you to give me. And how is notification actually service checking this? This is happening through now this middleware here that I promised about. Validate API key middleware. What it's just doing, it's validating if the API key in the header is the same as the API key that was issued to the client. And now here we are just calling that method we have seen to validate the API key. So you understand, this is one way of protecting actually two services that don't know each other through and have them connect through a secure way. So by doing so, notification service will know, okay, any clients that want to connect to me will have to provide a secret key that I issued to them that will know that I will trust whatever request they're trying to give. Of course, this can be developed further, but we're just having a glimpse into it. So now, this is only notification service trying to authenticate its request. People who are hitting notification service. What about the event service? So in some ways, let's say the event service will hit the notification service to send email notification, and notification service want to confirm back, because those two services, remember, they're not microservices. They are just two third-party services that don't know each other. So in some ways, notification service, event service will have to be sure that this notification service really sent that email. And to do so, notification service needs a way to communicate back to the event service and tell them, okay, event service, don't worry, I've sent your email, right? So to be able to do that, notification service has to have a way to communicate with event service. So in the other way, event service has to provide a way for notification service to connect. So event service now decides to create another API endpoint to expose to notification service. So in the event service now, we are going to expose another API endpoint. Do that. And that we're gonna call confirm notification sent. So this endpoint will just be exposed to any third-party service that the event service uses. And so they may just communicate back and acknowledge, okay, whichever notification was to send, we had sent it already. So don't worry, perform any action. So event service is going to expose this API endpoint so that notification service hits it back to confirm that, okay, I've sent your notification, right? So event service doesn't know also notification, or the event service doesn't trust notification service. Because you remember, there are two services that don't know each other, but they have to communicate in some way. So event service is going to expose this, but even though it's public, it also has to have a way to check who is communicating to me, because you just don't have to misuse me however you want, right? What event services now decides to do is going to also want to validate requests that are coming from notification service. But in this case, notification service is kind. It's like, okay, I don't want you to do anything, but in every request that I'm going to be sending to event service, I will be providing a key, right? To tell you that event service, it's me, trust me. And remember, notification service had issued before an API secret key, right? So we had seen that notification service had issued the secret key to event service. So event service knows this key here. It knows that, okay, this is my key, and no one else has this key. So if notification service contacts me with this key, I will be sure that this is notification, because no one else knows this key. It's only me and notification service. So if notification service contacts me back with this key, I'm pretty sure that must be notification service connecting back. So notification service now decides in each request that I'm going to be passing to you to event service, I will be sending this key, and event service will know that, okay, this is notification service that can take me back. So this whole concept is actually known as webhook request, if you have heard of the term. So it's a hook that event service is providing, and a hook can be integrated, can be hooked with anyone can hook into that hook. So in this case, notification service is gonna hook with that with event service to confirm back. So whenever now, let's go back to notification service right here. Oh, okay, we are there. So under app service, when the email notification is sent, we see we have this sent email notification method right here. So when the notification is sent, we want to connect back to event service. So we have sent the notification. Of course, here we are just logging, not doing anything crazy. But you want them to confirm back to event service that, okay, don't worry, you have sent the notification now, proceed with what you want to do. So what event service is going to do is going to connect back to event service and send another request, another HTTP request. And as well, in the header, you can see notification service is going to provide a key. In this case, we don't call it actually API key. You can call it whatever you want, but I just call it NS to mean notification service key. And this is going to be a key that's going to be passed to notification, so from notification service to event service. But this time, notification service want to be a little bit more secure. They don't just want to provide that key back plain as it is. So it decides to hash that key so that when that key is received, only the event service will know what that key is. So notification service actually decides up here where are we getting the key? It's right here to hash that key, to hash the API key up. Remember, it's the same API key, my API secret key. That's notification service now decides to hash. And we are hashing it through that algorithm you see right there. And it's actually a mechanism that hashes in one way or encrypts in one way. So it's not like a cipher. You know, when you actually encrypt your cipher, you can decrypt that. But hashing with this method, HMAC, we only hash one way, encrypt one way. We cannot decrypt. And the only way to know the value of that, the real value now that is passed, is the only the person who has that secret. And remember, the one person who knows this secret is the event service. So you understand that no one actually in this case can be able to guess what value notification service has sent back apart from the event service. The only way anyone can know is if they know the secret key. And the secret key is, we assume event service has kept it secure, so they didn't expose it to anyone. So this is actually a more better way to communicate as well back to a service, to another service, and letting them know that you are actually the person they think you are. So you hash that key in a one-way hashing, which cannot be decrypted, and only the person who has the private key will be able to know the real value. So once notification service actually send the request with this value in the header, what the event service is gonna do, we can still go to app service, and under app service, you see under here, sending the notification. No, it's under here, confirm notification sent. This is the method that's going to be hit by the notification service to confirm that they have sent the notification. Of course, it's as well another HTTP request. So you can see how an API context called which is public. So what it's going to do, what event service is going to do, it's going to have another middleware. Remember, middleware is a middleman in between. It's going to intercept any request coming. So it's going to say, to any request that actually comes, I want to check if the value that's being passed is the correct one. So you can see right here what it's doing. It's as well encrypting again the API key and then check if those values are the same. So with the HMAC mechanism, you cannot have a crypto-decrypt method. No. It's only the person. So the person who sends the request, they have to hash on their end, and you who receive the request, they have to hash on your end. If you compare those, they have to be equal to be correct. So if they're not equal, then it means there are two different private keys or two different things that were requested. So on the end of the event service, it's going to hash as well the same API key, which is right here, and compare if the two are the same. If they're not the same, then it's gonna reject that. It's gonna know, okay, this is not the person I think it is. let's discuss as well. So we are just going to pass here another key, or just a slight change right there. Yep. So if we go back to Postman and let's try to make another request there, we're still having another batch request. So wait a minute. I think we didn't change. I wanted to see this. We didn't change the change we did before. I think it was right here. Yeah, for the numbers. I don't know, but it's supposed to fail. Supposed to fail. Either I did a change. I don't remember where I did it. Yeah, it's gonna fail, and you're gonna return an unauthorized. I'm not gonna throw an unauthorized exception. So it's gonna deny that request and say, okay, you are not the person I think you are. The other thing is you can as well change the key or change the algorithm that was used. It's still gonna fail. So if you change one of the two, it's gonna fail. So you have to the encryption has to be the same on both ends. So if the notification service encrypted with that algorithm there, you on your end you have as well to encrypt that algorithm. So if you use SHA-1 or whatever 256, you have to use the same. If you use SHA-12, you use the same as well. Yep. So this is another way, enhanced way we can say of ensuring the communication is secure. It's between two unknown parties that try to communicate. All right, so let's assume everything is okay. I'm going to remove all changes that I've made. Just a minute. Um, so let's move a little bit further. Now we have finished the assume we are done developing our application. And our application is ready to be deployed to production. I mean, we have to put it to the end of users. And then what are we gonna do? Remember, the intent here is to see how we can integrate security in our development flow, in our development journey. The journey ends in production. So what we're gonna do, we're gonna say, okay, let's test now our code. Is our code secure? I finished building our code, building my application. Is my application secure? Did I miss anything? Of course, we are humans. And to do that, we're gonna try a new tool. I think some of us are already familiar with security tools and IDEs, but we're gonna use one actually that I think you know already, Sneak, right? And we're gonna tell Sneak, try to go through our code. Just tell me, is there anything I omitted? Right? So what I'm gonna do, I'm gonna call Sneak. That's right there. Okay, I'm using PHP Storm, and then I'm gonna tell Sneak, please, I beg you, just scan my code and tell me if there is anything I missed, right? So Sneak is gonna go through our code and try to find is there something that you probably omitted or a bad practice. Uh, so we can see already that somewhere in our code, Sneak is not happy, right? It's not happy with us. So right here, we can see it's telling us it has coded secrets, which is true. Because you remember, we are passing the secrets plain as is, but we shouldn't, right? And it's telling us, suggesting us, boy, try to fix this, use at least the environment file to save them. So that's one way we can actually ensure that our code quality is actually better by integrating such tools, in our flow, development flow, to scan our code and sometimes tell us, okay, that's critical. We can see as well right here, it's telling us something. Oh, okay. I'm having a promise here that it's my pay at some point. I didn't catch it. So you see, this is not actually a crazy thing, but just reminding me that maybe you should just catch it in case it fails, right? Which is a good thing. So this is one way we can as well integrate security in our development flow to know to check on our code whether the quality is actually good before shipping our code to production. All right, so not everybody actually has a crazy laptop to run all these in their machine. Some people might prefer, I don't want to do this. Maybe my RAM is just it's not good capacity. I don't have a good CPU. And running this actually will slow my development. But don't worry, people thought about it. So they created cloud tools. And so Snake thought, all right, let's give you a way to do that, but in the cloud. And now we're gonna try to integrate Sneak with our repository online. So whenever we push our code, Sneak is just gonna scan them online for you. So you don't have to use actually your computer resources. Oh, so what you're gonna do, you're gonna go to Sneak Cloud, which is right here. And yeah, you just see the URL. You can just log in and you're gonna have that also there. And right here we have actually projects where you can add your projects. And once you add your projects, you can actually do the same scan we just did locally, we can do them online. And once Sneak actually is done, it's now gonna give you the same report. So you can see it's telling us after analyzing our codes right here, we have two critical actually conditions, two critical things that we have to fix. And one of them is the hard-coded API key. So it knows, it's smart enough to know that should be private, shouldn't keep it. And if we go a little bit further, it's going to even give us some suggestions. I think right here. So let's see the full detail. And yeah, just giving me where I made that thing and fixed analysis. Actually recommend us a way to fix that and telling us, well, maybe you can have a secret in environment variable, you put your secret keys, and you can just proceed further and you will see all the suggestions that Snake provides you. So you see, by doing this, you are actually putting Snake with GitHub, and it's just going to be scanning the project to test if there is any vulnerability. Of course, it's not only that, you can also go through your dependency tree and go and scan the dependency to build out the tag, any vulnerability found, and all of that report given to you. So this is actually it's just a quick and slight walkthrough on how it feels like to have security practices in our development flow. Thank you so much. Any question or anything you want to add on? Most welcome. Yeah, that's it for me. Any question from you? Was I too fast? Something wasn't clear. Um, I want to hear. I hear from you. You want to add on? You want to comment? You had fun? It's complicated. I don't think. Are you lost? Do I have to go through it again? Yeah, anything. Yes, please. please. If you can have the mic. Okay, let's say for example when you're implementing something to do with the credit cards, because most of them use the PHP function that you are saying. And people tend to add the test cards and then they hash it and then they give the value. So I wanted to test the people that when you do that, remember to remove the test accounts, because if you don't remove the test accounts, okay, when someone gets the code, you can be able to undo the hash and then you get the real counts. So when if somebody is able to like, dump the hashes from the database, so using the hash value and the original text from the text there, can be able to undo the hash and get the real counts. Thank you. Oh, great. Anyone? Anyone else? Any add-on? Any comments? Yes, Rachel? Something? Okay, so if you're okay, all of us, then thank you so much for listening to me. We're gonna have a quick networking break, and we come up next with the other speaker. Thank you, and enjoy the rest of the sessions.
Yes, so my name is Tony. I'm going to do a presentation on supply chain security for Flutter and that projects on GitHub. Yeah, so a bit of myself. I'm a Flutter developer and also a coding instructor at Polytechnicals, which is a CBO that sort of empowers women through STEM skills. Yeah? Where we teach people how to code, tracks ni tofauti, kuna website development. We also do mobile app development with Flutter. We have collaborated with Google to teach people Flutter. Also, we teach digital marketing, how to market yourself online as a business or as an individual. Then there's also 3D printing we do. Yeah, so within the Flutter community, we also have Flutteristas, which is a group that we started some time last year for teaching people Flutter, specifically ladies, but also guys we are invited to come. Yeah, so to start us off, we're going to talk about what supply chain is basically, and the whole security aspect of it before we dive in to looking at it in Flutter with GitHub. Yeah, so in the from just a general perspective, supply chain in any industry basically is just the whole process that something has been created from the source to the end user. Yeah? So all industries have their own supply chain. Yeah? Hata kama retail, whatever industry you think of, unakwanga na a supply chain. Yeah, so for software development, basically is from where you write your code to you deploy that code, then distributing that code, then when your end user uses your product, yeah, whether it's an app or is it a web app, yeah, whatever that you deploy finally, yeah. So there are so many points in that chain that can be vulnerable to attacks. So we're going to explore some of those vulnerabilities later. Yeah. So why does it matter? Why does it matter to implement security in every chain in your development process as a developer? So number one is integrity. Yeah, so if you make public how you secure your software in the development cycle at each stage, each iteration, your end user, it sort of gives trust. Someone is able to yeah, these people are trustworthy. We can actually use their products. Yeah, so security enhances that integrity. So everyone is in the industry can trust your product that it's good to work with. Yeah? Then there's also the issue of IP. Yeah, so we know that there's a lot of cracked versions of many apps out here. For example, something like Spotify. Most people run Spotify app cracked. Also many others, especially in the Windows ecosystem. Yeah, so with the implementing supply chain security, you are able to protect that, especially for your builds, whenever you deploy them to the world. So you are able to validate your software to ensure that you're the one who actually owns it. Then the other thing is availability guarantee. Yeah, so what does that mean? Yeah, so if you have your security in each stage, it ensures that every time, for example, you release a new a version, a new update for your app, it will always be available for your end users. Yeah, so it's sort of the whole supply chain, putting security and everything. It enables every time a new build, anything that happens, someone is able to secure it really well. Yeah? Then the other thing is user trust. Yeah, so user trust and integrity insurance sort of work hand in hand together, whereby if you're able to secure everything, your user is able to trust your product. Yeah, so let's just do an overview of that and Flutter. What is it exactly? It may be familiar to some of you, it may not be familiar to some of you. Yeah, so that is a programming language for building things on the web, mobile, and server applications. Yeah, so then we have now the framework. So with the that, you write that code inside a open source framework known as Flutter, developed by Google. Then you're able to like deploy your apps in the various ecosystems, iOS, web, even on Android. Yeah, so that's like what it does basically. Yeah, so if you want to get into this, you just go to data.dev, you go to flutter.dev, you get all the SDKs over there, then you can start like installing, for instance, like doing mobile app development. Yeah, if you have any issues, you can always like reach out to me, we can like solve them. Yeah, so why does supply chain security really matter in in that and like the Flutter ecosystem? Yes, so the first thing, the reason that Flutter and that are open source projects. So like there's like a lot of people all over the world building and contributing to like build on these frameworks on open source repositories. Yeah, so this is very very important for everyone to like be concerned with the security of Flutter, because those code bases are public, like for everyone. Yeah, so it's very very important to like think about security, because you're dealing with like maintainers, the people who own it, and like the contributors. Then the other thing is the rapid development cycles for Flutter, when like someone is sort of releasing an app or a new feature in that open source project. Yeah, so like with open source projects, we know that like there are many people contributing. So every time is always a release, maybe to fix some vulnerabilities. So it's very very important to consider putting security in that whole process. Then the other thing is widespread adoption. Yeah, like if you look at like industry statistics, a lot of people are like moving to Flutter because of its cross-platform nature, whereby you just have one code base, put it in all those ecosystem, and it's also like fast to like build apps on it, secure. Yeah, so it has like a lot of advantages that is making people like move to Flutter. So the fact that a lot of businesses are using Flutter in their products, that means it's attractive for malicious people to like sort of introduce maybe things such as uh, code to like interfere with your Flutter app. Yeah, so it's also good for like also like for 0 days. Yeah, you know that 0 days like exists out here. So it's like really really good to think about putting security in Flutter and that SDKs. Yeah, so let's talk about some of the threats that are involved in a supply chain. Yeah, in most like common like build processes for most development, yeah, you have like something that looks like this, whereby you have like your source where you write your repository, where you're going to like build it, then you put it in a package, then like the final user uses that package. Yeah, so most development cycles are normally like this, like at the backbone. It's normally how you have something like this. Yeah, so from one point to another, there's always a threat in this supply chain. Yeah, so like for example, like from the developer to like the source code. For example, you have a source code maybe on GitHub or all those version control systems that you might know, like a GitLab. So someone might like submit some bad code to the repository. So it introduces vulnerability onto that supply chain. Yeah, so maybe this person maybe doesn't have those like administrator privileges. So someone's able to like introduce code, bad malicious code at the source. Yeah, then from the source to like where you know you are going to like build it, there might be uh, processes in between the CI/CD. Someone can still introduce bad code over there and interfere with that. Then we use a lot of dependencies in building our apps and our web apps and all that. So these third-party dependencies, someone might have a corrupted dependency, thus making your build be vulnerable to maybe attacks or whatever. Then the build platform itself, most of these build platforms are also like open source repositories, so they might also pose as threats as them as having like build, so it can be compromised. Then almost the same thing also the package to the final user. So the final user might also get a package that is not right. Yeah, good example is like the versions, the cracked apps. So your end user might get a cracked version maybe of whatever app they're using, then vulnerability gets introduced. Yeah, so it's very, very important to like mitigate these threats. So we're going to look at how Flutter does that. Yeah, so the current landscape in data and Flutter, how they sort of secure every stage of supply chain. The first way is through provenance. So this is what like the team at Google like does currently. Yeah. So they protect their builds through provenance. Yeah. So what is provenance? So provenance basically is putting all the information that you've used to like build your software that you're creating. Yeah, it's normally like a JSON file, whereby you say the packages that you've used, the machine that has been used. Yeah, so if like the Flutter SDK at Google, they have provenance for a Flutter SDK. So they can from that JSON file, you can actually know this Flutter SDK, the machine that built this SDK, the packages that were used, the timestamps when it started and when it ended. Yeah, so that's information that can be really verified through your provenance architecture. Yeah, then Google also has this security framework known as SALSA that they use to ensure their SDKs and the Flutter packages are compliant in the supply chain security. So in full, it's supply chain levels for software artifacts. Yeah, so the main idea around this framework, so it's an industry standard that was created by like Google and like other companies in the ecosystem. Yeah, so with this standard, it's one is able to like you build whatever you're building, then you ensure it meets the standards of this framework. Yeah. So if you like go deeper into this framework, you realize there are 4 levels of security. There's like level 1, level 2, level 3, level 4. So level 4 being the highest level of security for your apps. Yeah. So you realize that, for example, in level 1, they say you provide like all the information for your like your builds and packages and all that at the smallest level. Yeah. So you have to like put all that information in a provenance for level 1 level of security. Yeah, then with level 2, they say you also have to like publish your open source like your source control for building your builds. Yeah, so you have to like ensure that that is also compliant. Then you have level 3. So level 3, your builds and your source control, they have to be sort of verified. They can be authenticated. That's such that if someone comes and like audits your provenance, they're able to like see, like to track from like the build stage to like the final end user product. Yeah. Then level 4 is like the highest level of security, whereby like people can actually look at the software, is able to like anyone can like trace, and no one can like change anything in your software without like having another person approving that change. Yeah. So like there are 4 levels. Yeah. So if you like go to that site, like you learn more about how Google uses this for their apps. Yeah. So focus areas in Dart and Flutter, it's mainly 2 areas with like that ecosystem. Yeah. So number 1 is the Dart and SDK software. They are normally created and like are compliant with that SALSA framework that I've like mentioned. Yeah, so you realize that SDK, like with their engines, you realize like with like that SDK, Flutter SDK, they sort of are compliant like up to like maybe like level 2 of the SALSA framework. Yeah, then maybe the Flutter engine and like the final whatever product someone's going to use like to build on Flutter is compliant maybe at level 4. Yeah, then another way of like securing this supply chain for that and Flutter is having tooling that improves the Flutter ecosystem and like everyone who's using Flutter. Yeah, so other than just the SDKs, there are also things known as packages in Flutter that third-party people can use to build packages that do specific things on Flutter. So these are like the dependencies. Yeah, so Google has a way of finding ways to like secure that for the supply chain so that no one can just easily inject any package into like the pub.dev repository for that is malicious. Yeah, so they have like tooling to like mitigate that. I'm going to like look at that. Yeah, so for GitHub now, specifically for GitHub, one way they implement that is through something known as security advisories. And so on GitHub, if you like browse your GitHub, you realize there's something known as GitHub advisory database. And so this database is like an open source database that people like sort of like report and are able to like catch and fix vulnerabilities before like the public is like made aware of that. So there's like every framework that you can think of. If you look at that database, there's like already predefined like charts. If maybe you're building on that, pub, whatever, you'll see every person who's contributing to like maybe report a vulnerability to like fix it. So with the Google collaborated with like GitHub, so they put that over there and it's supported. So like that package managers are able to like collaborate with other reporters to fix those vulnerabilities before privately before announcing them publicly. Yeah, so if you are a Dutch developer, maybe you are creating your own package to do maybe something. If it's like maybe you're deciding to come up with a package, maybe for like payment with like compressor. Yeah, so you can like add this to your repository so that you're able to like have a security advisory so that you can like allow others to like come and like look at whatever package that you're building, see if the vulnerabilities, report it, just discuss within yourself before putting it in public. Yeah. Then there's also like a CVE. If you don't find a vulnerability that is already listed, you can put it on that database. Yeah. Then also something else, you can also have your own security advisory for your own GitHub repository. Yeah, so every time you create a repository, you can have a security advisory for it, whereby people in the contributing to that repository can sort of find vulnerabilities and mitigate them. Yeah, then so just a screenshot of how that GitHub advisory database looks like. So you, as you can see, there's like reviews, like reviewed. There's like composer, Elang, GitHub Actions. So like on the left, these are all the reviews advisories that already exist on that open source database. So you'll see if you select like for the pub is one for the DAT, you'll see all vulnerabilities that are associated with the pub package. Then people are like collaborating to like fix them. Yeah. Then the other thing is dependency graph. So if you are a person who creates projects and put them on GitHub, you know that there's a tab for dependency graph under insights. It's under like the insights tab. Yeah. So with this graph, sort of lists all the dependencies that you have used in your projects and like the versions. Yeah. So for specifically for that, there's normally a pubspec.yaml file that's the one that lists all the repositories that you've used in a Flutter app. Then after that, it generates a graph. Then from that graph, something known as dependable. I know most of you like are familiar with it. It finds a something compromised in a repository. Maybe you've exposed the AKs. It sends a pull request. Then we're able to like accept that PR. Then we are able to like allow it to solve whatever vulnerabilities that you have. So like that sort of forms the basis for dependency board. So the dependency graph looks something like this. So you have your repository, your code frequency, then you are able to look at all the dependencies that you use in your Flutter project. Yeah, so from the dependency graph is where we get now the dependables. So the dependables looks at the dependency graph, sees vulnerabilities, then it sends a pull request to you as the owner of that repository. Then you are able, it can automatically update your packages. For example, using updated packages. Yeah. So a good example of this is here, whereby if you can like analyze this repository, you notice the dependable. There's like a repository known as Pana. So it has checked in the pubspec.yaml. It has noticed that that analyzer, like the previous version was 4.7, now it's 5.0. So it's sending a pull request down to like update it for you. Then you're able to like update that automatically for your dependencies in Flutter and your that packages. So that will like bring me the end of this session. Yeah, it's very brief because in that and Flutter, GitHub already they collaborated to like create for coders who build on Flutter and that SDKs security for that. So you don't have to like, do a lot. You just go to your GitHub repository, ensure you have your dependables enabled. You have on GitHub on your GitHub repository, ensure you're on a security advisory if you're like building in public using that package. Yeah, so that's it. Yes, anyone has questions, can ask. Yeah, you can also connect on Twitter, GitHub, and LinkedIn.
I think it's afternoon. Um, I'm glad mko hapa. Thank you for making the time to be here. Um, I know imekuwa cold morning, and I'm glad you're here to attend my session. So I'm going to be talking about AWS Lambda and resilient architectures. My name is Jacob Moracha. I'm a software developer. I'm also the AWS user group lead, one. I'm working on a certification for the cloud. So it's something I've been working with for the last almost 2 years. So today I'm here to share a little bit about my experiences, my knowledge about building resilient applications. Anthony was talking about Flutter. She spoke about WordPress. He spoke about Node.js. So at the end of the day, after building all these applications, where do they end up? They end up being deployed on the cloud. And in most cases, we often ignore. You just deploy, it's working, and it's done. Um, Around 8 months. Yeah. But so today I'm gonna take you through a few things you should do maybe to ensure that your applications um, are secure. Number one, they're resilient, and my definition of a resilient application, I think, is how fast do you recover when a disaster occurs? How long does it take you to recover from that? That is my definition of a resilient application. So we're gonna be going through event-driven architectures, and then we go through there's security, um, the key pillars of building resilient applications. There are advantages, and many more things. So number one is event-driven architectures is a modern architecture where you build applications from small decoupled services. So you're building applications, what I could describe them as microservices, each application running on its own. Uh, but at the end of the day, they connect together to perform the specified whatever functionality or business logic they are supposed to achieve. So unlike the traditional models, the monoliths, where you're building the whole application just a single application handling all the things, we do lose coupling between the producer and the consumer. So the producer is an example of someone who is consuming whatever comes from that application. Let's say an e-commerce shop, you go online, make an order, buy something. You are an event producer. And then there are consumers who now return, update, or such stuff. So this is an example of an application. So in between the event producer and the consumer, we have an event router. It's an ingestion. It does ingestion, filters, and pushes the events to and from the consumer. So for instance, someone goes on a retailer website. You make an order. It's sent to the ingestion to the event router for filtering, and then a request is sent to the warehouse database to check if a product exists. And then that request is routed back to you to update you that this product now exists. You can go ahead and make an order. So once you make an order, um, the next thing is payment. You pay, and then the next person who comes in is now the customer relations. So if you look at this whole, it's driven by events. Something has to occur for the next event to be triggered. So some of the benefits of EDA are they scale and fail independently. So you have an application, let's say a microservice messaging running on its own, authentication running on its own. So when part of the application fails, it's only that piece of the application that fails. The whole system doesn't go down. And then there is agility in terms of development for people who write code, um, in the sense that so let's say in a team, this encourages the agile practices where everyone is working on something and then you just come in and piece it together to make up the whole system. It boosts morale, I could say, in terms of how we develop systems and such. And then building extensible systems, extensible in the sense that you can build very huge applications, because you're building them in pieces. So it's so if you look at building with agile practices, you are breaking down the application to smaller pieces. So if you break down to, you make it, the more you make it smaller, even if it's that huge, that big scale, the more you make it very small, it's very easy to build and scale that. And then it reduces complexity, that's easy. And then auditing is, in case of errors, bugs, and such stuff, it's very easy to know where they occur from and trace them. And then we have cutting cost. Building on serverless architectures, in most cases, it's a pay-as-you-go model. You are paying for a service. You are paying for the function invocations that you make. You are paying for databases. You are not paying for idle resources. So it somehow cuts the cost you have to pay. For example, when you are building monolithic applications, you have to procure the whole system. When you are ready, maybe for deployment, you have to buy, let's say, a VPS, a database, and this. Give it a rough estimate of the amount of money that it will cost you. So with these services, for example, if you're using Lambda and Amplify, they scale. They scale vertically and horizontally. This means that they scale with databases and the VPCs, the processors, the memory you need, all these scales as you as your traffic or let's say the people who are accessing whatever resources you have on your site increases, traffic spikes. So, and then number two, we have application design patterns. These are standard, could say industry missions. They are defined. They are meant for problems or challenges that happen regularly while building applications. So there are a set of design principles tailored for cloud services. There are software design principles too. These are for cloud, and some of them to apply still to the software world. So they should be speedy, simple, and singular. Number functions should be very speedy because the event driven. There isn't that, what could I say? Like so you need to make an invocation for an event to occur. So it just has to respond to that and that's it. Then you think of concurrent requests, not the total requests, in the sense that um, the moment you're making a request, that's what runs. The next request creates its own. So normally, for example, cloud functions run on it's I think it's volatile memory, one that it only exists during the time you are sending a request or processing something. And the moment it's done, that's it. Next thing is share nothing. You create a function, it runs. Once it's done, the only thing that remains is, for example, data that you need to store in a database. Beyond that, nothing exists in your service. And then you assume there isn't a hardware affinity. I've had this. For example, in teaching business, someone asking you, you know, you build, for example, a mobile application. What about Mama Mboga who uses a low-end device? What about someone who needs a USSD application? All those, I think, are kind of resolved with this design architectures where now you are designing applications for the cloud. The moment you're done with that, the cloud will handle the other part of that. There isn't things to do with designing hardware in mind, or designing the user in mind. Um, and then use events to trigger transactions. Uh, when using, I'm going to insist on when using event-driven architectures, your applications are very fast because your application runs only when an invocation or a function or an event is met. That's when your application responds to whatever you have. And then design for failure and duplicates. Uh, duplicates not in the sense that you're designing, let's say, a function running 100 times and duplicating that in your database. No, you're designing to ensure that whatever your application does, it can replicate it or do it more than once or twice without affecting anything. It's like testing whatever your application does. Yeah. Um, so these application design patterns have their own their six pillars. So operational excellence, your application um, should or has to solve some business case or deliver something business wise. And then there is security pillar. It should be secure as much as possible, reliable in terms of um, can I, for example, it's an e-commerce platform. Can I shop on this anytime I want? How long does it take, for example, with downtimes and such stuff? Then there is performance and efficiency. How fast does it respond to requests? Cost comes in as one of the big major arguments, especially with serverless architectures, especially when you are comparing AWS, there's Firebase with Google Cloud, there's Azure and such. Um, how optimized are your applications when it comes to cost? Are you just paying for resources even when your application is in idle state? And then, is it sustainable in the long run? Are you just spending on it? Are you just running it and consuming resources? What do you get in return? Um, so these are some of the examples of use cases. For example, choose the right runtimes to use. For example, AWS provides you with popular runtimes. We have an Node.js for Lambda, Python, and Java, .NET. And then use layers for code sharing. These is to avoid duplication. And then there is VPCs for Lambda functions. That need private access to your network, provide that access to ensure that they are efficient as much as possible. This is done with the IMI roles. IMI is like a template you use to specify roles for each application you create on the cloud, specifying this application will access this resource to this extent. So is a big topic. Maybe you can go through the AWS documentation to understand how AI works. And then control traffic flow between your serverless components using step functions for orchestration and use the API gateways for APIs and endpoints. So there is SNS, simple query services, and the SNS for synchronous messaging services. This can also be used to report, especially when there are issues, for example, errors and stuff. so they can be used to report back to you, update you in case something happens. And then you need to implement failure handling, logging, and monitoring this to ensure that in case there's a failure, it gets to be updated very early. AWS provides you with a dashboard specifically designed. You can go check out what functions have been failing, what my functions have been running, how much resources have they been consuming all this time they've been running. It makes it very easy for you to trace those errors using logs. Logs actually have the timestamps for every event or when it occurred, so it's very easy to trace it to wherever it occurred. And then there is optimizing for cost and performance by setting appropriate functional memory sizes, caching, batching, and using Fabric for intensive workloads. And then you need to automate deployment. There is the AWS service application model. There is the cloud formation, which help you in automating this. There's also issues to do with environment variables, secret keys. I use AWS systems manager parameter to store them. And this one provides you with an access key. Only your Lambda functions have that access. So once they know an event, they can just send the key with that event. The same way when sending an API request, you send it with a token. So if you send that, you send it with a token so that that request can be handled with the backend, like an authorization mechanism. So AWS gives you system manager parameters to store these configurations and to ensure that they are safe from any issue. And then we have monitoring and observability. I don't know what it means. So monitoring and observability are crucial for understanding performance, the health, and so there are a few key terms. There are more than these that can go check out. So for example, metrics what resources are available to what extent, how much, for how long. Those are metrics. And then logs are timestamps. For example, I know you PHP should so if you have an application on server, probably there is a process called includes every single event that occurs within your application within the time there is case your application has a problem, has a dependency issue, and directly report. You can actually set them up to report to your emails. Visualization is provided by AWS. It's a dashboard for error reporting and monitoring your applications. You can observe every single event happening with your application. And then there is tracing. This is now after you get the metrics and the logs, you can trace wherever this error occurred and then debug it. And then the errors are eventually things that were not expected, abnormal behaviors within your applications. So in AWS or serverless architectures, monitoring and observability are crucial for understanding the health of your application. So these are some of the tools that AWS provides. AWS CloudWatch for monitoring, and then we have alarms. We have AWS X-Ray. That's the same thing, just like an X-Ray. Checks through your application. Provides extensive reports of whatever is happening. We have CloudWatch logs. These from the AWS CloudWatch. Something happened somewhere. You can check through the AWS CloudWatch logs and then find out what happened. Actually, with last week was AWS event. They launched some very interesting things because right now you can copy error message directly from your console and then paste them into yeah, Amazon queue and check through the database. They say that they trained Amazon queue on 16 years of data. That's a lot of information. I've actually tried it. It's very interesting. Has a lot of information about AWS. It can help you learn so much. Then there's logging. These are like how events occur, an analysis of that provided by AWS, and there's asynchronous notifications. And then we have error handling mechanisms. We have a retry mechanism. An error occurs, so to confirm that it's an error or somewhere in your code, it has a problem. So with the retry mechanism, you are running the code again and again. Though this time you are running it without, let's say you're just running it isolated somewhere, not affecting the part of the application, just trying to understand what is happening. And the letter queues. This now after retrying and eventually whatever you're trying isn't working, it ends up in these DLQs for data checking. Then there's throttling and timeouts. This happens. It's not working. It's not in the DLQs. So eventually your functions time out and stop running to ensure that you don't consume any resources anymore. Lastly, we have the security part of this. Of my presentation was very short. So if you're sleeping, please wake up, take this home. We have the security part of this. And this is very essential. I think as most of the people here are developers, most of the time we ignore security. We just build and ship. That's it. You don't care. Some time back, I was asking someone, "Do you think storing environment variables in the env file is secure?" And they're like, "Yeah, it is." But how sure? You just write in code and clone it and you're done. Sometimes you end up with the environment variables on your GitHub. It's exposed. Um, Security is key. I think as much as we are building applications, you need to ensure that they are secure. So with AWS, there is IMI roles. This provides you the way to make sure that each service you procure on AWS has a specified level of access. It has you specify which resources it will access and cannot go beyond that. Then we have data protection, ensuring that data in transit or somewhere idle in storage is secure. We have using Amazon CloudTrail to ensure the information you're putting out there is safe. Um, oh, this is not working. This is very interesting. So lastly, I want to talk about something interesting as part of security. One of the partners or the sponsors of this event are Sneak. Sneak is kind of a tool. It provides you with a way out of the box to ensure that when developing your applications, they are secure as much as possible from the initial, from the start, where you're starting developing from. It has a VS Code extension. I've been trying it. It analyzes your dependencies, tells you which vulnerabilities exist, If we install it on existing repositories on GitHub, it's gonna raise pull requests, letting you know that, for example, these icons, the version you are using is version 4 and we are version 5. Actually, it's something that affects most of us as developers. You have an application running on not version, I don't know, 2, you have version 19 or something like that. These are things that expose our applications so much. So please go try it. It's you'll find it interesting, and I'm sure you'll come back with some feedback. I thank you for listening, and yeah, any questions? You must ask a question, even if it's minor. You don't know. Okay. Thank you. Enjoy your lunch.